Okay, hello everyone. I think now we can start. Welcome to this webcast by AnyBody Technology, which is on how to batch process the AnyBody models. So this is the outline of the presentation and the webcast for today. So we're going to start with some intro slides by me. My name is Mohammad Sharif Shurija. I'm an R&D engineer at AnyBody Technology, and I'll be acting as the host for this webcast. And we're going to move on to the main presentation by my friend and colleague Morten Lund, who is also an R&D engineer here at AnyBody Technology. He will talk about some intro to macro language of AnyBody, and then how to run AnyBody models from Python. And he's going to showcase some good examples and demoing some simple examples on how to batch process the AnyBody models. And he will give you also some practical and ongoing project called Lifelong Joint. And I'm going to wrap up with some final words at the end, and we're going to later on move to the Q&A session. Okay, so just some intros about AnyBody modeling system. So AnyBody modeling system is a multi-body kinematics and dynamics analysis tool, which is the software. And then we have a collection of models called AnyBody Managed Model Repository, or in short AMMR, which has different applications and different examples that you can start with. So if you have a specific research or a practical application and you're using or you'd like to use AnyBody, so most of the time you can go directly to the AMMR, pick up one model and start from there. So you don't need to create everything from scratch. However, if you have and want something very customized, you can use isolated links, isolated segments and muscles, and those things and you can customize everything or build from scratch, of course. We have a wide range of options or simulation features that I'd like to highlight. So standard use of musculoskeletal modeling and simulations is for motion capture, where you have some data through your gait labs, for example, and you want to look at how it moves, and you want to look at some of the variables. So that's very easily done in AnyBody. And then, for example, if you're in your lab, you don't have 3 force plates to simulate a full gait cycle, and you still want to simulate that full gait cycle, of course. So we have a tool called ground reaction force prediction, where we look at the equilibrium equations and we try to estimate the ground reaction forces and moments. And it's been validated, so it's fairly and very reasonably accurate. And this tool can also be called, in general, reaction force prediction or external force prediction, depending on where you draw the borders on your dynamic system. We also have some imaging techniques where you have, MRI images, so you can use the information of the segmentations of the MRI images and use those to even further individualize the generic models of AnyBody to your patients or subjects. And also we have a very nice solvers and in general tool to simulate man-machine simulations. Mainly it's called SolidWorks to AnyBody. So if you have a very detailed CAD model that you have designed it with different details, so you can import the mates and parts of SolidWorks into AnyBody automatically, and those will be converted to rigid body segments and rigid body joints automatically. And also you can have constraints of the environmental devices. For example, if you have a CAD model that is in interaction with the human body, so there will be some constraints in terms of kinematics and motion between them, so it will be very easily done in AnyBody. So I'd like to talk about some applications of AnyBody. If you look at the top left one, this is what we call the mocap modeling. So it's very classic that you have gate lab, for example, or motion capture lab, you have a bunch of cameras, and you have force plates, you have EMG systems, so a bunch of equipments that you have there. And you can use the mocap data, the motion, namely, and the ground reaction forces to simulate a motion that is called inverse dynamics, for example. And you can look at some variables. You can also have designs and how to make your design better. So if you're a mechanical designer, think of design optimization. So normally this design optimization is not done in interaction with the human body. Just think as a deeper level and as a level that is interaction with the physiological aspects of human body. So you can do ergonomic analysis. So think of just a car model. If you're thinking of steering wheel, for example, the frame size, whatever, where should it be, where should be the location, or how should it be designed and formed to maximize human comfort. And you can do pre and post surgery predictions. So you can have a comparison of between pre-surgery and post-surgery to evaluate the outcome of surgical actions, and you can have finite element analysis by using the outputs of AnyBody. So just looking at it from a closer point of view, so if you have an environment model, it can be an exoskeleton, it can be, let's say, a device, it can be an implant, or you name it. And then we have the generic musculoskeletal model, which is based on specific height, specific mass and inertial properties that you're going to scale afterwards. And we have some input data that can be motion and forces. This is just a classic way. So we have ways to predict motion. We have ways to predict forces, like I said. But then all these will come together, and then you have a single dynamic system, and then you can run dynamic analysis or mainly inverse dynamic analysis, which includes the recruitment of muscle. And then you can simulate that, and you're going to have your model running, and you can look at the internal variables or loads of the body, which are mainly muscle forces, variables related to muscle in general, speeds, for example, if you want to look at tendon properties, if you want to look at the muscle part, active part, passive part, you can decide on what you want to look at in terms of forces and kinematics. And also you can look at the joint forces that include the contribution of muscles. So classically, people when look at joint forces, they don't look at the contribution of muscles. And then like metabolic energy of the muscles, etc. And then you can post-process this, which I think will be the main focus of the presentation by Morten. And one example can be post-processing it to finite element tools. And you can close the loop and then make the loop for the design optimization. So you have some inputs, you create some outputs, and you give feedback to a post-processing tool, and you close the loop to do optimization. So this would be the main simulation framework or one of the complex simulation framework that you can think of. So with this, I'd like to pass the word to Morten, who will be the presenter, and then he will talk about how to batch process your AnyBody models.
Thanks a lot, Mohammed. So I'll take it from here if you can make me the presenter. I think I can even do it myself.
Okay, so I think now you should be the presenter, Morten.
Thanks a lot. So I'll start the slideshow here. Thanks a lot for the introduction, Mohammed. So today we're going to talk about batch processing. And the first thing you could ask when you talk about batch processing is why do you want to automate your simulations? I guess the best argument for that is really reproducibility. Even if you don't want to do batch processing, having a way to automate your simulations means that you won't rely on actually clicking around in the GUI application. Could also be that you want to explore the effects of different inputs of your model. And one example of this is, for example, this webcast which we had last year on some work by Kasper P. Rasmussen and John Rasmussen from Aalborg University. They ran 16,000 simulations with like a model sitting in a car seat, and they put this model into different positions and typed in different kind of anthropometrics, segment length, etc. And running 16,000 simulations is, of course, completely unfeasible when you have to do it in the graphical user interface. But you also might just have a lot of models and you just want to batch process those kind of models. And tools for doing these kind of things is what we're going to look at today. But before we get started, I think I'll just introduce a small example model that we'll be using for this webcast, because it's a good example of how you create models from the AnyBody managed model repository. So we're gonna start out with a very, very simple model, maybe the simplest you can get when you want the whole human. And it's basically a script that looks like this. On the top line, we have a line that basically includes the AnyBody managed model repository. In this case, it's the one that is installed together with AnyBody, the read-only version of that. And then here at the bottom, you can see that we include the human model, and these few lines of code will basically give you a model that you see here on the right side, a full human with all the different segments in and with muscles on. But this model is maybe a little bit heavy for the examples that we're going to use, so we're going to create two define statements that turn off the arms, basically. And we're also going to turn off one of the legs with a define statement, and maybe also the muscles on the trunk. So doing this, we end up with a simpler model like this that only has the right leg and muscles on. And for this example, we're going to change this model so it can run moment arm studies. So basically, you want to investigate here the moment arms, maybe around the hip. And to run moment arm studies is also quite easy, because these kind of studies are actually built into the model. All we need to do is enable them, basically. And there is also a switch for that. All of those switches here are also documented in the AnyBody modeling system. If you load any of the examples in the MMR, you will find documentations on these kind of switches. But with a model like this, it will basically look like this when we bring it into AnyBody. If we load it, we will see here in the model tree that inside the human model folder, we suddenly have a new folder called Evaluate Moment Arms. And it has a subfolder called Right and Leg, and then it has a number of subfolders here: hip flexion, hip abduction, basically a study for every kind of joint that we have in the leg. And I think we're going to look at hip flexion, and if we run the hip flexion study, the model will perform hip flexion as you see here, and the output of the model will be the moment arms of those muscles. So I'll just launch AnyBody, and we can take a look at this model here from the GUI perspective. So loading up the models, we will see we have all the studies out here. We have the study for hip flexion. We can run that. To run it, we select the study here in the study tree, and then we click the run button, and then the study runs. After it's run, we could maybe export the data from within AnyBody. To do that, we will find the same folder here in the model tree. I'm showing you all of this because later I'm going to do it using macro commands, so you can see this similarity. We have to find the right folder here. Evaluate moment arms, right, leg, hip flexion, and then study. It's quite deep in here. We have the output folder for this study. We could imagine that we were right-clicking this output folder. We could save all the data from that. We could also find the moment arms in here. Here we have, for example, moment arms of the psoas muscles. You can see the moment arms. There are also some of the muscles that don't have a moment arm at the hip. There will be virtually 0 here. But if we have any of these, we could export the data. There is a right-click the file, the variable, there is a dump command. It will dump out all the data to the console window down here. But there's a lot of options that you can do when you are in the GUI interface. You can also open the chart view and plot it. But doing these things in the GUI window has the big disadvantage that if you want to repeat it tomorrow and easily recreate your plots with some new changes, then it becomes quite annoying to work with the GUI. So let's go back here. So the question is, how do we automate this? And to do this, we are going to use the console application of AnyBody. And if you haven't seen that before, it's located inside the AnyBody install directory. So here you can see we have the AnyBody exe file. This is the GUI version, and then just below we have the AnyBody con.exe. That's the console application of AnyBody. So I'll just launch the console application. Oh, basically just a command prompt, and then I can write here AnyBody. I created a link for it. So if we launch the AnyBody console application, it basically just starts up and gives you a command prompt, nothing else. So what can we do here? Yeah, but here we can type in macro commands. And the macro command is, for example, a command to load the model. So we created this model called hip.any, and if we type load hip.any and press enter, that model basically loads. And then we can start to do more things. Well, I'll get back to that. But first, let's take a look at what macro commands are available. So for everything you can do, or for the most important things that you can do in the GUI application, there is a corresponding AnyScript macro. You could imagine that you clicked the load button up here on the GUI. There is a corresponding load macro command. You could select operations in the operations tree. There is a corresponding macro command to do that. You could click the run button and there is a corresponding macro command. You could also right-click, as I showed you, some of those variables in the tree, and you would have some options in the right-click menu. Those options are called class operations, and there is also a corresponding macro command for doing these kind of things. But just typing in macro commands at the prompt doesn't really automate stuff. So to really get the benefit of this, we are going to put these macro commands into files. So here is just an example of a macro file where we've typed in those macro commands. And then we can pipe this macro file to AnyBody. And to do this, we'll say AnyBody.con.exe, and then we'll give it a small argument -m. This means that we want to use a macro file. And then I'm going to type macros.txt. This is the small example file here. And starting this up will automatically load the model. It will select the operation that we want and run it. So now you can see it's running kinematic analysis, basically doing the moment arm study. Then it finished, and then after that it dumped the rectus femoris moment arm. So you can see that there is some data here. And then it exits in the end. So I hope this gives you an idea of how you could batch process, and maybe we could use even some of those simple tools here in your workflow. But as soon as you want to do something that is a little bit more advanced, it also becomes maybe a little bit annoying to work directly with these macro files. But there is a tool to help you doing that. So we created an interface from Python to AnyBody. And Python is an object-oriented programming language. It's quite easy to learn, and there's a large ecosystem of libraries for all kinds of scientific stuff. If you don't know what I'm talking about, then you can think of Python as being sort of an open source version of MATLAB, very simplified. So now I'm going to switch to some live examples to show you how you can do this, how you can work with AnyBody from Python. So I'm just going to switch to the browser here, where I have another presentation. So to work with AnyBody from Python, we're going to use a small open source library created at Aalborg University. It's called AnyPyTools. And AnyPyTools will help us handle all the interaction with the console application. It can help us create these macros programmatically, run simulations in parallel, so you can speed up your batch processing. So it has a lot of neat features. And to get started with this, what you really need is a Python installation, and you need the AnyPyTools library and all its dependencies. The easy way to do this is to install a Python distribution, a scientific Python distribution that already has all those necessary packages installed. A good option is a Python distribution called Anaconda. It has all the things included, and you can yeah, I guess Google is your friend. You can Google for it. It's created by a company called Continuum.io, and it's free to use and free for commercial distribution and all kind of things. So how do we do this? How do we run it from? Oh wait, I think I skipped the slide here. So yeah, how do you install AnyPyTools when you have installed this Python distribution? Well, all you need to do is really to run the built-in package manager which comes with this Python distribution. So if you installed Anaconda, you could basically just write conda install -c condaforge and AnyPyTools. This will automatically download AnyPyTools and install all the necessary dependencies, and everything will just work. So this is an easy way to get started. So how do we use it? How do we run the console application from Python? Here's a very, very simple example. The first thing we do is to import AnyPyTools, and AnyPyTools has a small class for doing these kind of process stuff, and it's called AnyPyProcess. So the first line here is from AnyPyTools import AnyPyProcess. And AnyPyProcess is a small class that we instantiate and save in this app variable here. So this slideshow here is actually a live example, and I can run these small snippets of Python code directly here. I'll try to do this. So here we imported AnyPyProcess and we instantiated it. Then we create a small macro list. These are basically just the same as those macros that you saw before, typed out manually here. When we created sort of macro like this, we pass that to AnyPyProcess. And AnyPyProcess has a small method called start macro, and if we pass the macro list to that and run it, then it will execute that macro in the background for us. So this is basically what happens here. I think it takes like 7 seconds or so 10 seconds. So we'll move on. But we can also execute several macros in one go. So here's an example where we have 2 macros after each other. One runs the hip flexion moment arm study, the other one runs the hip abduction moment arm study. And we can again execute those. And basically it will start up AnyBody twice, one for each of those 2 macros. It won't take long before it's finished. So what you may not see here is that you can get better performance if you parallelize the stuff. So let's try to create here 10 macros. So we can do that. So we've created 10 similar macros just as an example. And then we can start those up first sequentially. So let's try to do that. It will take a little while because now it runs those macros one at a time. I think the macros were set up so that it didn't actually run the kinematics. They just basically just loaded the models here to make it go a little bit faster. But the AnyPyProcess class has an argument where you can set up, specify the number of simultaneous processes you want to run. So in this case, it ran every time it finished one, it would start another. And then we can do the same with some sort of parallelization. So we can set number of processes to 5. And what it does now is that it starts 5 at a time. And every time one finishes it, it starts a new one, so that there is always 5 running at the same time. This speeds up things a lot. As you can see, we didn't get a 5 times speed up, but it really depends a lot of the computer. I don't have 5 cores in my laptop here, so I don't get a speed up of a factor of 5. It also depends a little bit on the overhead of running those models or starting them up and stopping them again. But on a fast computer, fast workstation, this really means a lot when you do batch processing. Then we can look about how to get data back from AnyBody. When we were in the console application, you saw we could print out data, but it didn't really give us the data to work with. But we can do this here. The usual approach in AnyBody is to use these any output file classes or save all the data as an HDF5 file, which you can later load into MATLAB or Python or other softwares. But it also has some disadvantages. For example, it's difficult to easily concatenate the data across different simulations, and it's quite impractical if you only need a few variables. And there is a better way to do this. And this is the class operations which I think we showed previously. This is the class operation called dump. And it will output basically just a single variable or everything in a folder for us. And AnyPyTools can automatically grab that output and bring it into Python so that we can work with it. So I have a simple example of that here. So in this small macro here, we load our small example model. Then it runs the hip flexion moment arm study. And then finally, we see we have two lines here, two class operations, which dumps both the rectus femoris moment arm, and then it dumps the joint angle for us. So we can run this small macro, and we will expect that we get the data from those two variables back. And you can see here that the output of running start macro here, we have assigned that to a variable called results. So let's take a look at what results contain. So we can see here that this results object, it's basically starts out here with a square bracket, and in Python terminology that is a list. So it's a list of stuff. And then inside you can see we have a curly bracket, and that's a dictionary in Python. That's something that contains something with some keys and then some values. And the keys here are basically our Python AnyBody variables, and the data are the data that we outputted. So now we've gotten the data back into to Python, and we can easily work with it. And we could, for example, plot it here. So I'm just starting up a small plotting library here in Python, and then I'm extracting the joint angle and the rectus femoris moment arms from the results object. So we could have imagined that we were running many macros. In this case, we only ran one, so we are accessing the first element of that result. This is the result of the first macro. And then we are accessing the joint angle variable. And we don't even have to write the complete name of the joint angle variable, which can be quite long. As long as whatever you write here is uniquely defined, you will get that variable back. So here we extract the joint angle and the rectus femoris moment arm, and then we plot that. So let's take a look at that. So this shows us the rectus femoris moment arm in the model. And it has a distinct parabola shape, which I think is what you would expect in this case. So let's move on. Let's see what AnyPyTools does besides this. It also allows us to handle errors. And when you work with these kind of models, you expect to get a lot of errors, especially when you build up the model. For example, even simple stuff like you misspelling operations or variable names. And AnyPyTools handles that. So let's create a small macro which selects an operation which doesn't really exist. If we run that macro, we expect that we get an error, and we can see here it says that one of the tasks failed, and it will also point us to a log file which we can then look at now. Or we could also look at the results, the result object. If we look at that, it says error main not a study on result object. So basically this is the error that AnyBody reported, which AnyPyTools then collected and presents to us. I guess we could even I think we'll skip that. I think we could also have looked at the actual log file. So if any error occurs, there will be a log file now together with the main file, and you can go in and look at that, and it will show all the. Let's just try it. See if that is possible. So I'm just going to copy this here. So here we got the log file from AnyBody of that one that failed. In the top part here we have the macro that was run, And then we have the output log. This is everything you would see in the AnyBody console when it ran. So you can see here we have the failure in AnyBody, and then AnyBody automatically exits. And this is also the failure that we saw in Python. So moving on, there's a lot of other features of AnyPyTools, and I'm not going to dwell into these things. Just going to mention a few of them, and then I'll let you explore yourself. There are some good tutorials on this. One of the more important features of AnyPyTools is that it allows you to create these kind of macros programmatically. Right now I've only showed you have to type all the macro commands manually, but it can be really a pain. If you imagine that you had a really large macro, then typing those out manually is almost impossible, especially if you then want to use this macro for moment arm studies or other kind of stuff. But here's, for example, a small example of a really large macro. It runs a Monte Carlo study. So in the beginning here, it sets a lot of defined statements, and then it also modifies some values with some random stuff. So this huge macro here would be really a pain to create manually, and especially if you want to have a lot of these, they're going to be different for every run of your Monte Carlo study. But AnyPyTool can help us there. And to show that, we can see here that AnyPyTools have a small sub-library called macro commands, and from that we can import a number of small classes for each of those macro commands. You can have a class to do load operations, operation run, dump, set value. The set value, for example, is an example here. If we imagine that we have these three values that we want to run our moment arm study with, it could be that we wanted to put the hip external rotation at different positions while we examine hip flexion. Then we can use this small class to automatically generate the macro commands we needed to set the hip external rotations in different positions. Other things that AnyPyTools can help us with is Monte Carlo simulations. It's also possible to do something called Latin hypercube sampling in order to run your simulations with fewer iterations. It can also help you if you want to wrap AnyBody with external optimizers, because it basically helps you create the bridge between an external optimizer and then AnyBody. So these are some good examples. There is a tutorial on this, but I'll get back to that later in the end of the presentation. So this seems to have been overflowed a bit. What it should have set up here in the top is batch processing. So that's we're gonna talk about different batch processing setup now. And the approach to batch processing really depends on how the AnyBody model is structured. If you have a setup with a single main file, then the workflow would usually be you would load the model, you would modify some parameters, then you would run it and save the results, and then you might iterate on that. And in that case, every macro that you create would basically be different. But you could also have a setup where you had multiple main files. And I'm going to dwell a little bit about that setup because it's really a useful setup when you do, for example, stuff like mocap models. And it's something that we use quite a lot. In this setup with multiple main files, then we have each main file really defines its own parameters, and then the macro that you use to run it will all be the same. Let me get back to the other presentation. Maybe I can show it better there. So here's a basic example of how to structure an AnyBody model so that you get multiple main files for each of your trials, which really helps you when you want to do batch processing, or also when you just want to work with the model in general. So the basic structure of a model like that would be that we would have a base model. This will be the model that all our trials basically used. You can see it here in the bottom of the files here, a base model. Then we would have a folder with some input data. In this case, we could imagine that this was C3D files for a mocap data file. And these input data would then be named in some systematic way. Here we call them trial 1 to trial 11. And then we will have some folders, and each of these folders represents a single trial. And those folder names we will often name with the same name as the input file. So every trial really have their own folder, and every trial have their own main file. So if we open up one of those folders here, trial 1, we can see there is a single main file in it for that trial. And if we look at that main file, it looks very simple. All it does is really include the base model and then set some parameters which are specific to this trial. Then when we later do batch processing, there is no need to change some variables because the main file has already done that for us. The base model, on the other hand, will become a little bit more complicated. Here I've taken our example from before, our HIP example, and I just added a section here that loads in some C3D data. And the C3D file that it loads, it basically finds the file name based on the folder that the main file is in. This is where it says AnyBody_name_main file here. So it constructs the file name for the C3D file it expects based on the folder name of the where the main file resides. That has a huge benefit. Maybe I skipped a little bit too far. Let's try to look at this in detail. So here I'll just open up a folder here with a small setup. So you see here we have all the trials. Since all the stuff in these different trial folders are basically the same, it's easy to create new trials. All we really need to do is just copy one of the folders and then rename it. So then we'll call it trial 8, for example. Since the C3D file that it looks for is basically constructed based on the folder name, then it's easy to expand this setup with new trials. And then we have a batch process file here, just a single Python script. We can also take a look at that. So this simple Python script here, it basically just does what you saw before. It imports AnyPyTools, then it creates a small macro. The macro is simple here. It's just load the main file, run the kinematics. And the macro will be the same for every one of those trials. Then we start AnyPy process up with that macro, but we supply it with one extra argument, which is called search subdirectories. So now I'm going to search out all those subdirectories which match this search string. And if it finds a subdirectory that matches this search string, or with files that matches this search string, it will basically execute the macro in that folder. So so this batch operation script here is quite effective. Let's show you what we can do. So I'm just going to start up a command prompt here. Then I'm going to type Python to invoke Python, and then this small script that we have batch process. So in this case here, we will we'll just give it a second to get started. It will search through all those subfolders. It will find that there are 8 folders that match the criteria, and then it will start up batch processing those. So I'm just going to stop it before it ends here. So before we finish off, I'm going to show you one real-life example which uses exactly the setup for a mocap model, and it will also show you why this has some real benefit. The setup is from the Lifelong Joint project, which is a Framework 7 EU project. It's a mocap-based model of HIP patients doing activities of daily living. It's a huge data set with over 150 patients and more than 2,000 trials. So I'll just see if we can find the files here. In this case here, the base model, which was just a single file before, is much more complicated. There's a lot of AnyScript files. But the setup is the same. We have this folder called subjects with a folder for each of our subjects. If we take one of them, we will see that inside a single subject there's again subfolders, a subfolder for each trial. We can also see here that there is a single file here which has subject-specific data, which is sort of data that is common for all of those trials, specific to the subject. We can then load one of those trials here. Let's take one of those standing references. And in here we see again we have a single main file, and we have a file with trial-specific data, data specific only to this trial. Let's take a quick look at this main file here. So this main file is simple. It imports this trial-specific data file. It imports the subject-specific data, which is just one level up, and then it imports a file which is specific to the whole experiment. You can call that lab-specific data. And then finally, it includes the base model. And that is all that is to this setup. It means that when we do batch processing and we figure out that some of the trials fail, it's easy to go in and find it. We just select the subject and the trial and then load it up, and we can run it and investigate further in the GUI program. And if you only had a single main file where you had to change a lot of parameters, you wouldn't be able to do this kind of thing. I also have an example of the batch processing script for this lifelong joint model. So this is what you see here. It's also a little bit more complicated than the other batch processing scripts that you've seen, but basically it's the same. It has three main groups that it runs. It runs all the calibration trials, then it runs the kinematic trials, and finally it runs the inverse dynamic trials. And we can just we can try here to run I'll start the calibration trials here. And if we do that, it will basically search through all the files that matches the search string for those calibration trials, and it found 184, and it has started them up or started running them. And doing so on a fast computer, then this probably takes an hour or so. Running the inverse dynamics, for example, down here takes quite a lot longer, but there's also maybe 1,000 trials or so. So it takes usually a night to complete that. Yeah, I think this brings us to the end of my presentation. Let's see, where were we? I think we'll go in here. If you want to know more about the AnyPyTools library, there is a tutorial for it. If you installed AnyPyTools, that tutorial will actually be installed as well. So you can go in and find the Anaconda area here, and there will be an AnyPyTools tutorial. And if you click that, it will launch an interactive version of the PyTools tutorial where you can run all of the different examples directly on your computer. If you just want to take a closer look at it, we also have a static version of that tutorial available on our wiki page. So I just show you here. Here it started up a notebook, Python notebook with this tutorial. And if we click, for example, getting started here, it will load the tutorial examples. And all of these examples are live, so you can run them directly here on the notebook. But basically, you can also take a closer look at the static version first, and you can find this on our wiki page. You go to wiki.anyscript.org, and there you can find a link on how to use AnyBody from Python, and there's a HTML version of the tutorial as well. So with that, I think I will give the word back to you, Mohammed, so you can finish off.
Okay, thanks very much, Morten. So I'm going to give you some general information. If you have any questions for Morten about AnyPyTools and general interfacing AnyBody with Python or anything else, you can send him an email. If you have general questions and inquiries about AnyBody modeling system and the company, you can send an email to inquiry@anybodytech.com. So we're going to have I think one more webcast in 2016, which is a very, very interesting application of AnyBody. It's actually a musculoskeletal modeling of dragonflies. So it's by our collaborators in Germany and England. So if you want to see some cool example of musculoskeletal modeling and still hear some techniques and theories about modeling of both humans and animals. So I think this webcast will interest you a lot. So I really encourage you to sign up and be there. We're going to have, and for the webcast in 2017, I think we're going to start in late January or February. So stay tuned. We're going to have a PhD course. It's actually another PhD course. We already have one in September. So this one will be in March next year. But the registration will open this month, November 28th. So if you have interest to learn about AnyBody or learn more about AnyBody with focusing on predictive simulations using AnyBody, just go for it and sign up. So make sure you visit our website, so you're going to see more about events, what we have and what's upcoming, and you can see the list of publications for that you can look for your own applications. And the wiki that Morten I think already mentioned, so for the AnyPyTools you can find some examples. They're very interesting examples about, let's say, SolidWorks to AnyBody, AnyBody to finite elements, ground reaction force prediction, and so on. And we have the forum as well that you can post your questions, how to do this, how to do that, if you get errors, if you want to debug a model, and so on. And make sure also you can visit our YouTube channel, it's AnyBody Technology, to check out our previous webcasts. Okay, with this, I'd like to go to the Q&A session. I have received several questions now. I'm trying to sort them. I think we're going to have time, Morten, for maybe 2 or 3 questions, given the remaining time. So let me start from this, which is more like a general question. So the question is about Python 2 versus Python 3 and how those are handled through AnyPyTools.
Yeah, AnyPyTools can be used with both Python 2 and Python 3, so there's no restrictions there. And I also think there's no restrictions on AnyBody anymore. At the moment, I think AnyBody is capable to work with both Python 2 and Python 3. I think it was restricted to Python 2 previously, but the new version of AnyBody, which came out a few months ago, I think, enabled Python 3 support as well. So it works with Python 3 and Python 2, basically.
Okay, the next question is about do you have or can you do similar thing for MATLAB or C++?
So basically, AnyPyTools is a library for Python, but the underlying mechanism of using the macro commands and stuff, that will work for MATLAB or other software as well. But you of course need to write some sort of framework which takes those macro commands, puts them into a file, and then executes them. I know of some of our users who have created frameworks like that for themselves for doing batch processing with MATLAB, but it's not something we have here, since we don't have a license for MATLAB.
Okay, thanks. The next question is asking about any limitation on the number of AnyBody instances using this Python interface. So any limitations in terms of the number of cores and also the number of AnyBody instances?
Well, that's a good question. Most laptops and workstations, they of course have a limited number of cores, but AnyPyTools in itself doesn't have any limits. If you were able to run it on a Windows supercomputer or something like that, you could basically run it with as many cores as you like. There might be some licensing issues, of course, but basically I think it will work with as many cores as you like. So that's not a problem.
Okay, cool. And I have actually one question for you. So in ergonomics applications, so sometimes people don't have the background for musculoskeletal modeling, and they'd like to have a simple GUI to just by changing a couple of parameters. So you can think of a static posture of like workers, and there's like a force. You can think of an end effector force at the hand, and they'd like to change that static force and look at the internal loads, including muscles and etc. So do you think this AnyPyTools can be useful, towards that goal?
Yeah, that's actually a really good idea. I guess if people have some good models which they wanted to wrap in some small user interface, then AnyPyTools would be fine link to create a link between a small GUI application written in Python, for example, and then their underlying model. Applications like that could actually be quite interesting, I think. So I would really like to see something like that, but of course it requires that you already have a model that you want to sort of build on top of. But I think this is basically a really good idea from sort of a vertical application, as people call them, where you have a small focused question in mind, basically.
Very cool. The next question is, are there any updates in terms of new commands available in AnyPyTools?
Well, yeah, I think AnyPyTools is updated once in a while also to follow the releases of AnyBody. But the best way to get updates is to go in where AnyPyTools is hosted. So AnyPyTools is hosted on a page called github.com, which is sort of a code hosting site. So if you go in there, you will automatically be notified of new releases and AnyPyTools, and you could also browse the code and see the source code and see how it works. And if any of you have questions on AnyPyTools, then writing on the GitHub page would basically be the best way to get answers, I think, or replies. So search for GitHub and then AnyPyTools, and I'm quite sure Google will tell you where to go. Yeah, I think also in the tutorials there is a link to the GitHub page where AnyPyTools is hosted. So that's the best answer to get news and updates on AnyPyTools.
Okay, with this, I'd like to finish the webcast. So I'd like to thank everyone for joining in. I'd like to thank you, Morten, for the very interesting presentation. I'd like to apologize again for our American friends and colleagues who actually, although it was Thanksgiving, they tried to join in and listening to our webcast. So I'd like to say happy Thanksgiving. I wish everyone a great day, and we'll see you soon for our next webcast. Thank you, and have a great day wherever you are in the world.